Find all discontinuities and describe what type they are. So discontinuities are where a function has an error, undefined. And so with fractions, it's usually the denominator. So that's what we're basically looking for most of the time, is we're looking at rationals, and we're looking where the denominator has an error. So where does the denominator have an error? Well, where it has an error is when the denominator is 0. So that's kind of what we're looking for with fractions. Now, logs have discontinuities because you can have a negative in a log. Radicals have discontinuities because you can have a negative in a radical. So remember that. Radicals can because you can't have a negative inside. Logs can't have negatives inside. Those are two other discontinuity issues and stuff like that. Trig functions can have discontinuities, like tangent, because tangents are fractions in disguise. You know, like if you think of tangent x, well, really that's sine x over cosine x. So really, this is a fraction in disguise. So really, you look at the bottom equaling 0. So with that said, we look for what causes errors, and that's where the denominators are equal to 0. So let's find out where the denominator of this equals 0. So I'm going to pull a GCF of 2x out, leaving me 3x plus 5. All right, and then when we do that, we set each piece equal to 0. It's called a zero product property, because when you multiply two things, one of these has to equal 0 for the answer to be 0. So let's find out what each or either of them could be. So for this one, we're going to divide each side by 2. That leaves us x equals 0. And this one, we're going to minus the 5 over first. We get 3x equals negative 5. And then we're going to divide by 3, and we get x equals negative 5/3. So these two are our discontinuities. They are discontinuities. Now, what type of discontinuities is a whole other story. To get those, we have to factor and see what happens when we factor and cancel, and hopefully something canceled out, and that's what creates the certain types of discontinuities. So to factor the top, you hopefully realize that is a difference of squares. So you hopefully realize that's 3x plus 5, 3x minus 5. We already factored the bottom. That was pull the 2x out, leaving me this. And when we do that, those disappear. All right. What that tells us is our function is f of x equals 3x minus 5 over 2x. What that means is this function and this function are identical looking, except this function has a pinhole where it crossed out. So there is a pinhole at negative 5. But there is a permanent issue at 0 because there's no crossing out the 0. See the 0 here? I couldn't get rid of the 0. I could get rid of this one, but I couldn't get rid of this one. So there is a pinhole here, and there is a permanent issue here. So what does a pinhole look like? What kind of discontinuity is a pinhole? And a pinhole is a removable discontinuity. So a pinhole is a removable discontinuity. It looks like this, and there's a hole. That's what's happening there. Where this one, you cannot remove. It is a non-removable discontinuity. This is a non-removable because you cannot get rid of it. Can't spell removable. It's a non-removable discontinuity. Okay. Now, I do want to talk about this. What type of non-removable discontinuity it is? There are two options. We have the jump, and we have the asymptote. And we'll talk more later about how do we know which one of it is. But right now, I'll just tell you that x equals 0 is a vertical asymptote. And I'll tell you more why later on in other sections, but it is a vertical asymptote. It's not a jump. Jumps tend to be with piecewise in general, so that's one way. But there are other ways to tell what type it is. Find all discontinuities and describe what type they are. So it's a whole lot easier to find discontinuities when it's a picture. A whole lot easier. So let's look at this. So a discontinuity first right here. That is a removable discontinuity. It's a hole. The value's down here, but that is a hole right there. So that's a removable discontinuity at negative 3. The limit at negative 3 is 1, but there's a removable discontinuity at 3. So I have a removable discontinuity, I'm abbreviate that, discontinuity at x equals negative 3. Sorry if I said positive 3 earlier. Sometimes I do that. But negative 3, because it's a whole. Next time, okay, right here, oh, there's another issue here. At negative 1, there's another issue. There's a break in it. I have to kind of pick up my pencil. There's a not very continuous. So the another one there, what kind is that? That's called a jump discontinuity. So I have a jump discontinuity at x equals negative 3. Okay, let's keep going. Right here, oh, asymptote. Asymptote, it's discontinuous there. So at 2, I have another type, and that's just an asymptote. It's a vertical discontinuity. So a vertical asymptote is a discontinuity. A vertical asymptote at x equals 2. So those are my, I don't see any other that's like jagged, but it's not discontinuous. It's just kind of, so that's the only places that I have discontinuities, and those are the 3 types. Graphing ones are really easy to see.